In this word problem, Amelia jumps from the end of a springboard that is 5 meters high and 3 meters long. Her jump is parabolic in shape, and she reaches a maximum height of 10 meters, 2 meters after leaving the end of the springboard. First, we are asked at what horizontal distance from the foot of the springboard's ladder does she enter the water. We're being asked for this distance here, from the base of the ladder to the point where she enters the water. The first thing I have to do in order to solve a problem like this is decide where my origin is in this situation. There's more than one place that I could put the origin, and I could solve the problem correctly with more than one strategy. But I'm choosing to put my origin right here on the water surface directly below the end of the springboard. That means that I have a y-axis here, and this is my x-axis. The point I'm looking for is going to be one of the zeros of the parabola, which has to have a y-coordinate of 0, and I am searching for the x-coordinate in order to answer the question. I have 2 points, which are the vertex and this point here at the end of the springboard. The vertex has an x-coordinate of 2 and a y-coordinate of 10, and the other point has an x-coordinate of 0, because it is on the y-axis, and a y-coordinate of 5, the height of the springboard. Therefore, it happens to be the y-intercept. Using this form of the equation, y equals a x minus h squared plus k, I'm able to replace my h and my k with the 2 and the 10. Then I can replace my x and my y with the x and y coordinates of the other point I know in order to find what my value is for a. Y is therefore 5 and x is 0. Simplifying, 5 equals a times negative 2 squared plus 10. 5 equals 4a plus 10. 5 minus 10 equals 4a. So negative 5 equals 4a. A is going to be equal to negative 5/4 or negative 1.25. Now let's replace the a in our equation form with negative 1.25. We have y equals negative 1.25 x minus h squared plus k. And I can replace my h and my k with the vertex. So I have y equals negative 1.25 x minus 2 squared plus 10. Since I'm looking for one of the zeros of this equation, I can replace y with 0 and solve for x. Moving the expression negative 1.25 x minus 2 squared to the left of the equals, I get positive 1.25 x minus 2 squared equals 10. X minus 2 squared, therefore, is equal to 10 divided by 1.25, which is 8. And therefore, if I square root both sides, I get x minus 2 equals plus or minus the square root of 8. I can now solve to find both of the zeros, which will tell me a point over here that I don't need to answer the question, and this point that I've been looking for all along. Moving this up here, we get x equals 2 plus or minus the square root of 8, which gives us 2 different answers. if we have 2 plus the square root of 8, that gives us 4.83. And if we do 2 minus the square root of 8, that gives us negative 0.83. This negative root is the one that I don't need to solve the problem that happens over here. So I cross it out. My answer is 4.83 meters. But that is not the distance from the foot of the springboard ladder. The 4.83 meters is the distance from the origin. So to give my final answer, I must say 4.83 plus this 3 meter distance equals 7.83 meters. That is the answer to question A. She enters the water 7.83 meters to the right of the foot of the springboard. In part B of our word problem, we find out that at the same time that Amelia is jumping from the springboard, Marvin is lying on the pool deck 1 meter from the foot of the ladder, playing with a laser pointer. The red dot from the laser shines on Amelia during her descent, when she was 5 meters above the water. This happens right here, where the straight line from the laser pointer intersects the curve from Amelia's jump. This point has to be at 4, 5. The x-coordinate is 4 because it is 2 meters from the point where Amelia jumped to the axis of symmetry of the parabola. Therefore, it has to be 2 meters on the other side in order to give a point that has the same y-coordinate, y equals 5. Therefore, 2 plus 2 equals 4. We have the point 4, 5. We also have the point negative 2, 0, which is the point where Marvin is lying. Remember, our origin is here, so he is lying to the left of that. He has a negative x-coordinate. We figured that out by saying the 3 meter distance between the ladder and the origin minus the 1 meter distance between him and the ladder means he is 2 meters to the left of the origin. We have negative 2, 0 as that point. We are looking for this point here. It has to have an x-coordinate of 2 because it is on the axis of symmetry. It is directly below the vertex of the parabola. And we need to know its y-coordinate in order to answer our question. We will start by finding the slope of the straight line using the slope formula. Slope equals y2 minus y1 over x2 minus x1. Using the points that we know, which are the negative 2, 0 and the 4, 5, we get 5 minus 0 over 4 minus negative 2, and this gives us 5 over 6 when simplified. Therefore, the slope 5 over 6 is equal to, in the slope formula again, using the point 4, 5, plugging it in here, 5 over 6 is equal to y minus 5 over x minus 4. When I cross multiply, I get 6 times y minus 5 equals 5 times x minus 4. 6y minus 30 equals 5x minus 20. 6y equals 5x minus 20 plus 30 is equal to plus 10. Therefore, my equation for the straight line is y equals 5 over 6x plus 10 over 6. I can simplify this fraction, but I choose not to. I will take care of it later. Now, to find the point that we're looking for, we just need its y-coordinate. We already know the x-coordinate is 2. So we take this equation, y equals 5/6 x plus 10/6, and we plug in x equals 2 into that. Y equals 5 over 6 times 2 plus 10 over 6. When I multiply this, I get another 10 over 6. Because I kept the y-intercept as a fraction over 6, I now have a common denominator. So therefore, the point is 20 over 6. The y-coordinate of the point where x equals 2 is 20 over 6. I will convert that into decimal, which is 3.33. But I am not finished answering my question. We know the coordinates now of this point that is directly below the vertex of the parabola and on the straight line. But the question was asking us what vertical distance separated Amelia from the laser beam when she was at her maximum height. What we need to know is what's the distance between the vertex and this point. In order to solve that, we have to take the y-coordinate of the vertex, which is 10, and subtract the y-coordinate of this point, which is 3.33. And therefore our answer is 6.67 meters. The vertical distance that separated Amelia when she was at her vertex from the laser beam directly below her was 6.67 meters.